again, it's Cliff from Down Under. I wanted to do a little video on production machining tips and tricks, and that's a little bit bizarre for me because my background is tool making and one-off prototyping, and so I haven't had much of a background in production, and I've had to learn in the last few years about how to do production and find out the hard way some of the tips and tricks that speed up the process. I bought my Toolmarks without tool changes for doing tool making work, for cutting cavities and cores and one-off prototypes. And then I found, sod's law, whenever you do that, more and more work coming in that's production orientated, as our industrial economy here in New Zealand has shifted away from the sort of heavy industry towards the light, low production run type niche market work. And so I've got sort of, in a way, inappropriate machines for the type of work I'm doing, but that gives me a unique opportunity to learn how to use those machines. And that's also fortuitous for some people who are working from home and they only have a similar setup to me, that I can pass on some of these things that I've learned, very often the hard way, and so you might find some of these little ideas useful. There are things you can do to speed up batch production runs of parts. This is a typical job where you might be machining a series of heat sink parts with the pockets and the holes. Let's just go through that quickly. So you can use 2 work offsets and 2 vices on, say, G54 and G55. You can have stops on them so that the part references each time to the same place. You can use drills that have different diameters. I'm not sure if you can see that very clearly. There's a 1/2 mil difference in the end diameter to the larger diameter, so that saves a tool change. And that's especially useful if you don't have a tool changer. But even if you do have a tool changer, it still saves time. So I'll just go through running the part now and talk you through that. Okay, so we load the parts in onto the parallels, so we get the same Z height position. The vices give us the Y position and the stops give us the X position. And we do 2 at once, so that process of loading and unloading is sped up. Of course, when we're setting the job up to start with, once we've set the work into the stops on the vices, a touch probe is really handy for this. You might be using the Hallmark impact tolerant touch probe. Come down and touch off your Z on G54. Find the middle between those 2 parts for the Y, those 2 faces, and for the X, touch off on the edge, and you've got your G54 set. And then with your manual data input, go to G55, enter G55, zoom over to here and find the middle, touch the end, do the Z, and then you've got both parts set up the same. It's really very quick and simple. Well, why don't I just do a probing routine? I know some of you don't actually have a probe, so let's just go through it. When we're setting up our work offset, we just index down somewhere near. We come, if I stand here, you might be able to see both Path Pilot and the job. So we come to this page, we go find center circle, set work origin on the Y. So now we're finding the Y position, jog over, we'll set the Z while we're at it in about the right place. Okay. Probe Z, set work origin. That's the Z set. Come over here, drop down manually, and this page again, probe X, set work origin. This one. So as quick as that, you can see I've set the X, Y, and Z on the first part work offset. Just demonstrating how quick a probe is. Okay, let's run the part now. So you produce your code with your CAM software and G54, and then there's different ways you can produce the code for the other offsets. In this case I've got one other offset at G55, where you can just copy and paste it at the end of the G54 code, or in between the various tool changes, depending on your job, and then just go in there and edit it and change that G54 to G55. Okay, let's run this now. Cutting out the pocket at this stage. We're on G54 offset. I'm trying to position the camera so you can hear me without too much machining noise. See if this is going to work. So we're just roughing out the pocket for the heatsink seat, and then we're going to zoom over to G55. So we'll go to tool change position, where I've just manually edited in a change to G55. Of course, you can get your software to edit, to automatically put in the work offsets for you, but I think it's quite a good practice to do a little bit of hand editing, and you feel a bit more confident about juggling your programs around. And there's a little bit of a rapid feed in the Z there, isn't it? But it's just a good idea to do a little bit of hand editing. Copying and pasting and putting in a G54, G55 is a pretty easy sort of thing to practice on, and you can just prove the program out by having the maximum velocity slider down really low and just creeping through it to test it. So we'll do a tool change now to the drill, and that will drill all the holes, both sides holes, without a tool change, because it's a step drill. Just going quickly through the step drill, I just got an old 4.5mm length, full length jobber drill, just an old one, and just ground it off with a cut-off wheel, turned it into a stub drill, split the point by hand there, and then ground the diameter down on the end, about 5mm on the end, enough for to go through the part, on this D-bit grinder that I've mentioned on other videos. So you can very quickly grind another diameter, and as long as you've got a little bit of rake on the front there, I don't know if you can see that, then it'll cut on the step as well. Okay, so we just press cycle start again and the program continues. So it's going back to G54. That was copied and pasted in there, or rather the original. So it's only going down so deep because it's the 4mm part of the step drill. And now we're going to drill 4.5 holes by going a little deeper. And then we're going to go to the copy and pasted G55, so it's the same bit of code but with a G55 in front of it. There's a few legacy commands in there that aren't necessary, but it doesn't really hurt to have them in. I'm not making thousands of parts, just a few score, so I just need to make some basic improvements to the cycle time. So you can see that saved on quite a bit of vice setup time and tool change time, and especially useful if you don't have a tool changer. Okay, so just going through editing the G-code. So we just go to File, we'll go to Edit G-code, and then we will copy and paste the first section of the milling code in behind it again. So this is it again, appearing for the second time. And can you see the cursor there? And on this line here, where G5.4 would normally be, we put in G5.5. And it's that type of editing that you need to do. Obviously you've got to do it again a couple of times to cycle it through the various positions and tool changes, but you can check it out by just running it very slow with the maximum velocity slider down low to check that you haven't made any typos, and tweak any mistakes, and then come back and run your parts. 3-jaw chucks with reverse jaws are a great way to hold small disc-shaped parts. You can have little packer parallels, probably 3 is a good number, to hold the part up the right height, and you can use one of those parallels as a location point so that you can screw it down and have a fixed dowel hole that locates the part in the rotary orientation that you want. Each time you just slip in a little pin, in this case just a drill, so that when you tighten it up, the part's in its correct rotary orientation. Here we have the part in position, located with this pin, tightened up, and then we can remove the pin. It's always good when you can get one tool to cut several tool paths. This is ground out of an old 6mm carbide milling cutter stub on the D-bit grinder, turn 90 degrees, and I'm using it to cut 3 different areas: to cut the engraving, to cut the countersink bores, and to cut the central chamfer. If you're like me and you're agonizing as to whether to get a high-speed spindle or not, here's a point worth considering. You could have a 5,000 RPM spindle and do the job in 8 minutes, but if it's running automatically, you can go away and do something else. If you upgrade to a 20,000 RPM spindle and you can do the job in 2 minutes, does that really gain you a lot? You've got a low-cost machine that's running automatically anyway, and you're going away to do something else. Well, that's probably enough clips to put together into one video on production tips and tricks. I could probably do lots of them actually on different subjects, because although my background in tool making and one-off prototyping is different from production machining, a lot of the disciplines and skills that I learned are very similar, and they just need to be adjusted a little bit to suit production work. So it's quite good for me too, producing these videos, because it helps to consolidate some of the subtle differences and mindset changes that I've needed to make by putting them in video. And some of the more technical details, I can actually re-watch the video and say, oh, that's right, that's how I did it. So thanks for bearing with me. Thanks for watching. Cheers.